Hi, my name is Baron, and this is an elevator pitch on the influence of hypothetical Planet 9 on dwarf planet Pluto. My mentor was Sophia Cressy, and I'm coming from San Diego, California. So here's a quick introduction. In early 2016, these two researchers suggested the existence of a Planet 9, and they supported their hypothesis with the irregular movements of objects in the Kuiper Belt. And they said if there's a Planet 9 like this, then it would explain all of these strange movements that we're seeing in the Kuiper Belt. And I saw this and I wanted to do a research not on if Planet 9 existed, but instead on how Planet 9 would affect the other objects in the solar system. So we used a simulation, and the simulation used a few methods to actually calculate everything. It used Newton's law of universal gravitation and Newton's second law of motion to figure out the gravitational force being applied to each object. And it also used velocity relay, which was um, it's just kind of an approximation method to find out where an object is going to go next. And it kind of just incorporates a timestamp into the kinematic equations, as you can see right here. And I'll talk more about the timestamp later. So we collected the data through the simulation, and it had 21 objects, the sun, 8 planets, and some major moons. We also had some dwarf planets, and we chose to focus on Pluto for the study because it's really far from the sun and it's really small. So we thought its effects could be seen more clearly from Planet 9. And we printed its position and velocity at each time step. And here you can kind of see a graph of how it moved in one orbit. And we tested the data with Planet 9 being 20 times as far from the sun as Neptune because we thought researchers said that would be how far it would have to be for us to have not detected it yet. And we did it with a mass of 20, 50, 100, and 200 times that of Earth. So we got the data, and to process it, we ran it through another code, and we went through every single line to find out some information about the orbit. And we got the orbital period of Pluto, the eccentricity of Pluto, and the semi-major axis of Pluto. And when we graphed it with relation to the mass of Planet 9, it was very linear. And we even did a quick linear regression on some of them. And we used least mean square error, and our R value, which is basically how close it is to being a straight line, was very close to 1. It was basically 0.999. So we got that, and it kind of shows a relationship between the mass of Planet 9 and these parameters. But we also thought that a bit more could have been done if if we wanted to take it farther, and how researchers might want to do it if we actually do discover a Planet 9. So the first thing we thought of was we could use a different algorithm such as SRK, and a high order SRK would probably be a lot better than velocity relay as a approximation method to calculate the movement of the solar system objects. And it would be probably pretty significant to add a lot more of the objects in the solar system that are kind of smaller, such as the rest of the Kuiper Belt. Um, Something we did in the simulation was we just leveled all of the objects. So I guess adding that third dimension could also change the results. And it could also be compared to how the objects in the solar system are currently moving to figure out, you know, compare them and see if it's actually correct and also maybe reach another conclusion. But here's my bibliography and thank you.